The force exerted by an electric charge at the origin on a charged particle at the point x, y, z with position vector r is f of r equals k times r divided by the magnitude of r cubed, where k is constant. Assume k equals 10, find the work done as a particle moves along a straight line from the point 2, 0, 0 to the point 2, 2, 3. The work done as a particle moves along the straight line is equal to the line integral along the curve C of f dot differential r. To evaluate the line integral and find the work done, we'll write the integral in this form here, where we write f as a function of t using the parameterization of the curve C, and differential r is equal to r prime of t dt. So let's first find r of t that would trace out the line from this point to this point. We'll notice how the x-coordinate stays at 2, so the x-component of r would just be 2. The y-coordinate goes from 0 to 2, so let's let the y-component be equal to 2t. The z-coordinate goes from 0 to 3. Let's let the z-component of r be equal to 3t. So this would trace out the straight line from this point to this point when t is on the closed interval from 0 to 1. Looking at our formula for f, we'll also have to find the magnitude of r. Let's go ahead and do that now. The magnitude of r of t is going to be equal to the square root of 2 squared plus 2t squared plus 3t squared. So simplifying, here we're going to have the square root of 4 plus 4t squared plus 9t squared, that's plus 13t squared. Let's go ahead and write this as the quantity 4 plus 13t squared to the 1/2. We're also going to need r prime of t. Let's find that now as well. R prime of t is going to have an x-component that's a derivative of 2, which is 0, a y-component, which is a derivative of 2t, which is 2, and a z-component, which is a derivative of 3t, which would be 3. And now let's find f of r of t. We're going to have k, which is 10, times r of t, which is here. So we have an x-component of 2, a y-component of 2t, and a z-component of 3t, divided by the magnitude of r of t cubed. Well, if we cube this, we're going to have the quantity 4 plus 13t squared to the 3/2 power. Let's write this as an x-component of 20 divided by the quantity 4 plus 13t squared to the 3/2, a y-component of 20t divided by the quantity 4 plus 13t squared to the 3/2, and the z-component would be 30t divided by the quantity 4 plus 13t squared raised to the 3/2, which means the work done as the particle moves from this point to this point along a straight line is equal to the integral. Again, we have f of r of t, or f of x of t, comma y of t, comma z of t, which we have here, dotted with r prime of t, which we have here. We have x component of 0, a y component of 2, a z component of 3, dt. And the limits of integration for t, as defined here, are going to be from 0 to 1. Our next step will be to find the dot product, and then we'll evaluate the integral. Let's do this on the next slide. So we'll have the integral from 0 to 1 of this fraction times 0, of course, is 0, and this fraction times 2 is going to be 40t divided by the quantity 4 plus 13t squared to the 3/2, and then plus this fraction times 3 is going to be 90t divided by the quantity 4 plus 13t squared to the 3/2. Notice how we can add these two fractions because we have a common denominator. So our new numerator is going to be 130t. Let's write this as 130 times the integral from 0 to 1 of t divided by the quantity 4 plus 13t squared raised to 3/2 dt. And now we'll perform u substitution where we let u be equal to 4 plus 13t squared, and therefore differential u is equal to 26t dt. Let's divide both sides by 26. We have 1/26 du equals t dt. So in terms of u, we can think of all of this as, again, t dt is equal to 1/26 du, and this should be 1 over u to the 3 halves, or u to the negative 3 halves. So the integral with respect to u would be equal to 130 divided by 26 times u to the negative 1/2 divided by negative 1/2, or 13 over 26 times negative 2 times u to the negative 1/2, which means with respect to t, we'd have 130 divided by 26 times negative 2, and u to the negative 1/2 is really 4 plus 13 t squared to the negative 1/2. Let's simplify here. 130 divided by 26 is 5. 5 times negative 2 is negative 10. So we have negative 10. Let's write this as 1 over the square root of 4 plus 13 t squared. So when t is 1, we're going to have 1 over, when t is 1, this is going to be the square root of 17, minus, when t is 0, we're going to have 1 over the square root of 4. And of course, the square root of 4 simplifies to 2. So let's write the exact value as negative 10 divided by the square root of 17, and they would have plus 10 divided by 2, or plus 5. So this would be the exact amount of work done as a particle moves along the straight line from this point to this point, or the decimal approximation, this would be approximately 2.5746. I hope you found this helpful.